We already discussed about this. Support vector machine is also one of the famous algorithm that is used to help you to map between input and output, because after all, we're looking for the mapping function or mapping boundary, the decision boundary that can help us to segregate. If we're talking about classification, then we're looking for decision boundary. If we are talking about regression, we're looking for a model that represent the data point, okay? So a support vector machine, let's say you have this example where you have the purple represent one class, yellow represent another class, male, female, whatever. So what does it do? As I said, in classification, we need to find the decision boundary, the boundary that can segregate between two classes. Okay, so assume this is your decision boundary. So this is what support vector machine is going to do. Plus is going to find the widest street. So it's going to look for the margin for this decision boundary. So this is your decision boundary in the middle. And then it's going to look for the margin of this decision boundary. Meaning, what does it mean? How to find the margin? In simple words, as if you push this decision boundary up until this decision boundary touch the first data point from the first class. So this is your upper margin, let's say. Or the other way around, where you move the decision boundary down until you touch the first data point from the other class. So this will form what's called look-like street, where you have a decision boundary with margins, okay? So this is your plane or hyperplane, also they call it hyperplane, that segregate between the classes, okay? So logistic, try to segregate, eventually gives us the probability. Here also trying to segregate by finding the widest street possible. So by finding decision boundary with the widest margin possible. Okay? Clear how support vector machine works? Why I'm saying widest margin? Because maybe someone would say, sir, we may have also other case. You may have another example where this is our decision boundary, right? And this is our margin. Yeah, that's true. This is another solution. Oh, here's already. Okay. Okay, so this is solution 2. The blue one is solution 2. The red one, solution 1. Then how support vector machine will have the final decision, which solution to take? The solution that have the widest street, the widest margin. This one will be your best solution. Clear? So you're looking for widest possible street. Why? The logic behind support vector machine to support this decision is as you have wider street, the chance of having overfitting case will drop down. Your model is less prone to overfitting, less, okay? As you have narrowest street, there's the chance of overfitting increases a lot. Okay, so the goal is to maximize the margin between decision boundary and the training samples while minimizing the error. The error here, what does it mean? The misclassification. Misclassification. Correct? Because this is how we measure the performance. Remember, if you remember from earlier slide, we said we have task, we have model, we have performance. So this one will help you to set the performance. Okay, if you look for the earlier, case, same. You see that produces the least error or classification error, means the misclassification. How about regression? So this is our performance. This is our performance. How about regression? Where is regression? That minimize the sum of squared error. You see, this is the performance. Because you may have many solutions. So when we talk about regression, the best solution, the one that give you the minimum sum of errors, of squared error, right? When we talk about classification, we're looking for what? Minimum number of classification error. Okay, this is quite important because if we don't have performance, then we cannot tell which model is better. Like here in the class, if I don't have assessment, then I cannot tell which student is better, has higher performance, right? So here it's showing you, let's say we have solution 1, solution 2. B1 is one of the decision boundary, and you have this widest margin street for B1, while this one is B2, and this is the margin. So which solution is better? B1. B1 because it yields highest or largest possible street. Support vector machine also can, when we talk about classification, also classification can be linear, can be nonlinear. So when we talk about linear classification, you're looking for straight decision boundary, correct? Correct. While if you have nonlinear case, so your decision boundary can be nonlinear, like the case here. So your decision boundary is nonlinear. Support vector machine can work on both, can help you to find linear decision boundary, can also helps you to find non-linear decision boundary. Okay? Also, support vector machine can be used for regression. So some algorithms you need to keep in mind. They can work for both cases, can help you to work on regression problem, can help you to work on classification problem. But not all. Logistic regression, only classification. Linear regression, only regression. But some other algorithm like support vector machine can work on both. Okay? So now what would be the objective of the support vector machine? In classification, we already discussed, the objective is to find the largest possible street while limiting the margin violation. Margin violation means the error. Okay, the error. And here in exact to be margin violation, even the data points that fall within the street. Okay. Now regression is opposite because remember regression is not about finding decision boundary, but is about fitting or representing the data point. So now for support vector machine, for regression case, is gonna try to find the widest possible street that fit as many as possible data points. That means the data point should be resided inside the street because this street should represent the data points. Okay, while in classification, the opposite. In classification, opposite. You try to find the widest possible street while the data points reside outside. Outside. Right? So the street must be empty. So you imagine you are the pedestrian and I found the street that represents between you. Should you be inside the street? No. There's a classification, you should be outside. If regression, then should be inside. Maybe I'm not talking about the actual street for car, but I'm talking about pedestrian line. Then you should fit as many as possible. Okay, so the objective for support vector machine can differ. So in regression, to fit as many instances as possible on the street, on, while that one off the street. So this is off the street here, should be this is on the street. So the data point should be on the street in regression case. In classification case, data point should be off the streets, outside the street. Okay, فهم؟ وتدا فهم؟ فهم.